Welcome to Feature Fridays. My name is Guy Bartram. I'm Director of Product Marketing here at VMware for our cloud providers. And today I'm joined again by Sachi. Sachi, welcome back. Do you want to just introduce yourself for everyone?
Yeah, hi Guy. Hi everyone. I'm Sachi, Technical Product Manager with VMware. I'm focusing on Tanzu integration with VMware Cloud Director platform.
And last time we discussed quite a bit about this, right? We've been through the whole container service extension, the deployment, the adding packages, the user roles, and pretty much everything in CSE 3.1.3. But there's one piece that we saved the best to last, which was the cluster API. Yes, do you want to just tell us a little bit about the cluster API before we dive into the version support?
Yeah, sure. So we launched the cluster API back in January to support multi-control plane based Kubernetes clusters deployment on VMware Cloud Director. And like the advantages of cluster APIs are well known. The idea is simple: to use Kubernetes clusters to manage Kubernetes clusters in a multi-tenant way. And it's important for VMware Cloud Director platform because a multi-tenancy is the core of the platform and the solution. And the cluster API provides that unique management plane for each customer organization. So it makes it completely isolated and secured workload clusters for each of our customers.
So this is kind of like an overlay kind of capability that sits over the top of the clusters, so you can run everything centrally, basically, in a multi-tenanted way.
Yeah, so each customers will have their management plane. So within their capacity or within their multiple org VDCs, they can have a single management plane to manage all the workload clusters within their organization, and other organizations will have no idea about with container service extension, we have single management plane, which is the CSE server that would manage the lifecycle of all the workload clusters. Over here, we are isolating that to each customer level.
Okay, cool. And we're also doing that, this is like an API function, isn't it? So it's not going to have a UI associated with it.
Yeah, as of now, it's all with a CLI, and we are using CSE based Tanzu Kubernetes cluster to spin off the management cluster, and UI will be planned to and it will be evolved over the period of time.
Okay, cool.
Yeah.
All right, so you wanted to, just before we get into this, then dive into some of the supported Kubernetes versions.
Yeah, so we recently launched CSE release 3.1.3, and we came up with a few additional TKG version support. So we now, like earlier, we used to support 1.3, 1.3.1, and 1.4. And now, starting 3.1.3 release, we also support the TKG version 1.5 and their provided Kubernetes templates, which we, like always, we download it from the VMware portal and then upload it on the shared catalog for customers' consumption.
Okay.
Yeah.
And is there any, obviously keeping up to date with these templates, you get the latest builds, more functionality in the templates? Is there different packages deployed, or what's kind of the idea behind keeping abreast with these templates?
So this release, TKG release, tries to come up with the latest Kubernetes templates support on the TKG version. And along with that, we also update our packages support on each of those clusters. And for CSE, what it means is we also support, in translation, we also support those latest version of Kubernetes on CSE.
So they just become available basically by nature of the template. Yeah. Okay.
Wherever the out of the box TKG functions or updates will be there, new security patches or updates, that all will be updated on the newest releases.
Okay.
Yeah. So with that, the other update we have is that we now include a KF controller and matrix server as Tanzu core packages on VMware Cloud Director. So earlier, when we installed the Tanzu packages, we had to install these core packages as an additional step. In this release, we are making as part of the TKG cluster. So when a developer or a user persona from customer organization is creating a cluster, they will see KF controller and matrix server out of the box. They don't have to install it separately.
Okay, so that's come down with the new Tanzu template, is that right? Or is this addition from CSE?
Yeah, this edition is from the CSE.
Oh, okay. Yeah.
So if you upgrade it to CSE release 3.1.3, you are going to see KF controller and matrix server of the relevant versions on your relevant TKG release. So, and the other additional support we introduced in CSE 3.1.3 is that earlier we used to have to create a default storage class before customers would create persistent volumes for their applications on the Tanzu Kubernetes clusters. Now, this requirement is going away because we have now automated this process of creating default storage class on the cluster while creating the Kubernetes cluster. So, yeah. So if you see, when you create a new cluster, you will be asked to optionally create the default storage class while creating the TKG cluster. So whatever parameters you define over here will be available on your TKG cluster. So users can directly plug to that or just define a storage class as default in their clusters to start creating claims and dynamically providing named disk on vCenter.
Yeah. Oh, that's a nice little shortcut. Saves some time.
Yeah. And last but not the least, we introduced support for latest Python libraries. So customers can really use any version like 3.7.4, 3.8.x, or 3.10.x versions to install the CSE server. So we have resolved a lot of Python library related dependencies or strict requirements in the latest release. So it's easier for providers to spin up CSE server on any operating system. Okay. And yeah, with that, we will switch to cluster API. All right. So cluster API for VMware Cloud Director. Now, this provides the standardized cluster API support for VMware Cloud Director. It means that we will be standardizing. I mean, cluster API is a standard open source project, and then we will have that standardized cluster API operations on VMware Cloud Director when it's established, right? And
what do you mean by multi-control plane there for TKG clusters?
Yeah, so till now, using CSE, we could create a TKG cluster with single control plane and multiple worker plane VMs. With this release, we allow TKG clusters creation with multiple control plane VMs as well. So in case that gives the high availability to your TKG cluster. So in case one control plane VM is going out of sync, then you have high availability for your using the remaining clusters. The value add is our management cluster as well as workload cluster. Both are multi-control plane capable with cluster API.
Okay, that's cool. Okay.
Yeah. So yeah, let's take a look at it in detail. So like just a quick recap on like what cluster API means is that we always create or define desired state of any Kubernetes cluster in the YAML file and then we apply it to your management cluster to create that workload cluster with those desired state configuration. And as soon as there is a change in that desired state, it will the action will be performed to reach the desired state. So this helps us in scaling the cluster or changing or upgrading the Kubernetes cluster. Like various operations can be done just by changing the desired state.
Yeah, and that's a standard sort of Kubernetes thing, isn't it? The pods and everything else in desired state. Yeah.
Yep. Okay. And so how does it look in our VCD? Like what it means to have cluster API in VCD. So the step number one is to give a bootstrap cluster that will be responsible for creating and managing a management cluster for each customer organizations. And the way we do is this can be any TKG cluster provisioned by container service extension, or it can be any kind Kubernetes cluster running in customers setting. We install cluster on top of it and cluster API component on the bootstrap cluster, which will spin up a new cluster, which will be your management cluster. Now, the question is, why do we need a bootstrap cluster if we are going to have another management cluster? So right now, you can still install capvcd on bootstrap and use it as a management cluster, but this TKG cluster doesn't have multiple control planes because it's created from container service extension. And when you are creating new management cluster, you can define that you can have multiple control planes on your new cluster. So to provide high availability, we create a Tanzu Kubernetes cluster with multiple control plane. You make this the management cluster by installing cluster API. And then on top of that, you can provide all the users in your customer organization to this management cluster, and then using cluster-cutl or kubectl commands, you can create and manage the workload clusters.
So I'm a little bit confused about the bootstrap cluster. Is this something that, so when you deploy a cluster with CSE, it's actually going to deploy a bootstrap cluster first?
Yeah, I mean, it is a normal CSE based TKG cluster. There's nothing special about
the nomenclature of a bootstrap, right? Got it.
Yeah.
And does that exist then? Is it something that kind of happens in the back end? Because really, you only care about the management cluster and the production cluster, workload clusters. Yeah.
So right now, bootstrap cluster is needed to lifecycle the management cluster. As we move, as we progress further, we will be able to manage this TKG cluster as a self-managed management cluster.
Okay. Yeah. Well, that makes sense. All right.
Yeah. And the recommendation to use TKG cluster is that you have stable infrastructure on VCD to keep your bootstrap cluster up and running.
So yeah, you've got TKG cluster there and IaaS VMware Cloud Director but then that's a TKG cluster running on the IaaS platform, right?
Yeah, so both of them will be running on the your customer organization.
Yeah. Okay. So it's not a different environment or anything else. Okay, it's the same.
Yeah. Right now it's not. If you're using TKG, yeah, this will be over here.
Yeah.
But if it is kind, then it can be like anywhere.
Yeah. I got it.
Okay. And then this happens for all like multiple customers. So say customer A is having their own management plane and customer B will have their own management plane.
Yeah.
So you can see these are completely isolated, and so this provides like complete isolation and truly multi-tenant from this point on.
So if a like customer A wanted to have multiple management clusters, then they still only have one Bootstrap TKG cluster.
Yes, but why I don't know if customers will have requirement to create multiple management clusters.
For HA, for resilience?
This management clusters will have multiple control plane.
Okay, so they're, all right, okay, they're multi-control plane clusters. All right, that makes sense.
Yeah.
Okay.
Yeah. So yeah, so this is the high level concept definition of Bootstrap management and workload clusters. And now next question to answer is how do we provide load balancing? So the answer is with NSX Advanced Load Balancer. So each multi-control plane Kubernetes cluster will secure one service engine group to provide load balancing, which we will look in the demo.
Okay. And
so
that's pretty much automated. You've got to have, obviously you've got to have NSX Advanced Load Balancer stood up and integrated into VCD, ready for CSE to start using and provisioning.
Yes. Okay. And with that, I'll walk through the steps for Bootstrap. So for cluster API, we are creating a new RDE on the VMware Cloud Director platform. The detailed steps are described in the blog post and on the official documentation. So we can look at like all the details over there. And I'm just describing level steps over here.
Yeah, no problem. So what's RDE, Sachi?
Yeah, it's runtime defined entity. So every time we have a new definition of a new defined entity, we use from the container service extension. We have to create that new definition of entity on the VMware Cloud Director platform. Since cluster API is one of those, we have to create it manually as of now.
Okay, that makes sense.
Next one is on device where you are planning to use as your end machine to access the clusters. We need to install kind, cluster-ctl, and kubectl. These are the prerequisites. And then once you have installed these, using the cluster-ctl commands, you can install these kubeadmin and the cluster API versions on that Kubernetes cluster. So this will happen on your Bootstrap and management clusters. And once that is done, you download the code for cap VCD and you make changes to or you customize your infrastructure details on two files. One of them is controller manager config file, where you define your definition of VCD infrastructure, customer organization, load balancing service, things like that. And on the customization.yaml file, you provide all the authentication parameters. So once you have done that, you just apply that configuration related to cap VCD on the Kubernetes cluster. And this will install cap VCD on your Bootstrap or management cluster. And basically your those clusters are ready to spin up new VMs or new multi-control plane Tanzu Kubernetes clusters on your VMware Cloud Director platform.
Wow, okay, got it. And is that customization.yaml file supposed to have a K, or is it actually...
Yeah, it's supposed to have
It
K.
is, okay. So
yeah.
I don't know much about the nomenclature used, but that's quite funny.
Yeah, let me actually give you a closer look on that. Yeah, I thought we will have that question. So here is the file. Yeah. So over here, we can see the example controller manager config.yaml file. So over here, you can see we have the customer org, the network, the subnet, the load balancer configuration, and the resource definitions like CSI, CPI, CNI versions. So this gives users flexibility of using whatever CSI and CPI versions they would like to use on their Kubernetes cluster, right? And the second one is the customization.yaml, where you define the username, password configuration, and yeah, that's all. So basically, either you can use as a provider, either you can create this for your customer organization or customers, or you can enable that specific user role to create the management and bootstrap cluster so they can self manage those management clusters.
And just being someone who's never kind of deployed this infrastructure before in my life, but you know, how specific is this to, you know, what a Kubernetes admin would do by default with just native Kubernetes? How kind of difficult would this learning curve be for them to then start doing this themselves with the cluster API?
So traditionally, if you are like, obviously the basic Kubernetes knowledge is required to manage and create Kubernetes clusters or management clusters. On the other side, we have very good training on modernapps.ninja website, where you can actually learn about Kubernetes and cluster API and all sorts of trainings you can do. The installation is not the simple part, is the simple part, but it's the problem when not a problem, but you need to have the core understanding of what went wrong. So the debugging part requires a little bit of experience for the user who is managing these.
Okay. So I guess the simple kind of simple level of managed service a provider could do is deliver all of this on behalf of the customer. So the customer's orgs are set up, the load balance is working, everything's ready to rock and roll, and they're just going to access it. Versus a kind of do-it-yourself approach where you give the tenant a role to be able to do this themselves, and then give them some instructions and guidance on how to do it.
Yeah, and as I said, right now it's all using the CLI, and obviously this needs to be integrated with UI. So at that point, I'm sure the user experience changes. That's all I had for the presentation, and I will navigate to the demo. So in this demo, we will look at how to, in this demo, I have already created a CAC-based Tanzu Kubernetes cluster and created a management cluster, and like created a normal cluster with multiple control planes. And over here, you can see the number of nodes and the components on top. So here I have, for each control plane, I have etcd, API server, controller manager, proxy, things like that. So once this is done, here you can see the cluster has multiple control plane and one worker plane VM. Now, what we will do is make this the management cluster. So to do that, I'll fetch the kubeconfig of this Kubernetes cluster, make it as a context so we can work with that cluster, right? And over here, I'm going to install the cluster API and kubeadmin components. And once this is installed successfully, we will install the capvcd component. And just like I showed the customization.yaml and the control config plane.yaml, we will plug those in to make this the management cluster. So really, there are just 2 steps to make your multi-control plane cluster to management cluster. There are just 2 steps: cluster cutter installation and the capvcd installation. Okay. And with that, So once this is installed successfully, we'll see 2 additional pods on our Kubernetes cluster. And after that, we install the cap VCD component. So here I'll just apply that default configuration. And once this is done, we'll have 3 main pods to look at. And here we can see we have now new pods for CAPI kubeadmin, control plane, bootstrap, and cap VCD system. So cap VCD system is the one which is going to interact with our VCD infrastructure to create and manage the further clusters created from this management cluster. And you can provide RBAC to your management cluster based and set limits on like how many clusters other users can create, what's the resource allocation within the customer organization. All sorts of operations are supported on this management cluster. And this is the command to actually create a new cluster from the management cluster. And this capi.yaml will have the definition of the cluster, like what's the name of your cluster. So in this example, it's workload cluster. How many worker plane and control plane VMs we are going to have, what's the customer organization, and who is the user of that role, who is the user who is going to create or own that cluster, things like that. And you can also provide the Kubernetes version that's available on your VCD organization. And let me quickly show you what's the replicas. So replicas is the one that will decide how many control plane VMs you can have, or how many worker planes. So here we have 3 control plane VMs and 1 worker plane VM. So once that is done, we are going to apply that to create a new workload cluster. And to debug, you can actually look at this logs for this pod for cap VCD to see what's happening while they are creating a new cluster, right? Using this kubectl logs command. So you can see all these step-by-step logs in that pod. Now let's see what we see on the VCD and when you create that cluster. So step number 1 will be DNAT rule to have the inbound access to that Kubernetes cluster, like always. And the second one is the virtual service. So each Kubernetes cluster will reserve one pool, and then in that you have routed and the external IP access to that cluster. And the other thing is we'll also look at the VApp once the cluster is successfully created, right? To check what happened to our workload cluster, we can actually see get machines command. So over here you can see what's happening to your cluster. So in this example, it's still creating some pods and some VMs, and then it will say that the status of the cluster is provisioned or provisioning or failed or anything. And then based on that, you can see the VApps getting created on your infrastructure. And this obviously will fall under resource boundaries you have for your customer organization, right? And after this, I will also show the workload cluster. So over here, you are going to see the workload cluster. So the question is, how do you download the kubeconfig of this cluster you just created? So to do that, you are going to use the kubectl command to fetch the configuration. So over here you will see the get clusters that the cluster is created, and the VApp is over here. So here you can see multiple VApps, one for the bootstrap, one for management, and one for workload. And just like any Tanzu Kubernetes clusters, it's going to see the networking and all the machine configuration, the firewall rules, everything over here. And even for workload cluster, we'll see a new virtual service and its related pool over here. Once that is done, you can check the pods on, not the pods, but let's just look at the machines. So we have multiple control plane machines for your workload cluster and one worker plane. And after that, you are going to fetch the kubeconfig of your Kubernetes cluster by using the kubectl command. So over here, so this is like downloading kubeconfig from UI. And then you can provide the name of your cluster.
Oh, I see. Yeah. Okay.
Yeah. And once that is done, you can change the context to your workload cluster to work with your new workload cluster.
Yeah.
And to quickly show you the kubeconfig, you have the API access point IP and all the details. So this is how you basically create workload clusters off of your management cluster. So how does this work in customer organization? User who created management cluster can provide access to your management cluster to all the users, and they can create a new workload cluster using the cluster control commands.
Okay, so they can be in charge of their own destiny there and just spin up what they need. Yeah.
Yeah, exactly.
Cool. Well, Sachi, thank you very much for showing me around. There's nothing else to see, is there? That's it.
Yeah, so this is the main part of lifecycle management of the workload cluster, and really the other operations are just like any other kubectl operations. So I didn't showcase them, like deploying persistent volume, creating services. Everything else is same.
Yeah.
The only thing is we are introducing new concepts for that are existing for cluster API into VCD's cluster API.
Okay, so making them more native to VCD so they can be used by VCD. Okay. And is there anywhere that people can go and kind of find out more information about the cluster API? Is there any specific blogs that you've written or any videos or assets?
Yeah, so the GitHub documentation page is pretty much up to date for cluster API. And I also published a blog post showing the steps in detail. So we can look at that
in the video.
Yeah.
Great. Sachi, thank you very much for all your time. It's been wonderful to walk through this with you, and I look forward to future sessions on CSE. Thanks a lot.
Yeah. Thank you. Thank you, Guy.